Today we will discuss convergence of filter in Hausdorff spaces. Now the theorem states that a topological space Xt is Hausdorff if and only if every convergent filter on X has a unique limit point. Earlier we have observed that in an indiscrete space, every filter on that space converges to every point of the space. That means every point of an indiscrete space is a limit point of every filter on that space. Here we have to show that Hausdorffness implies that every filter converges to a unique limit point, and converse also holds. Let us prove this theorem. Let topological space Xt be Hausdorff and F be a convergent filter on X. Then we have to show that F converges to a unique limit point. If possible, let F converge to two distinct points X and Y of X. By definition, we know that if F converges to X, then F contains every neighborhood of X. That means the collection of all neighborhoods of X, that is n of X, is contained in F. And similarly, since F converges to Y also, so the collection of all neighborhoods of Y, that is the neighborhood filter n of Y, is also contained in F. Since Xt is Hausdorff, and we know that if space is Hausdorff, then for every pair of distinct points, we can find disjoint neighborhoods of those points. And so there exist neighborhoods n of x and n of y such that n intersection m is 5. As n belongs to F, since n of x is contained in F, so every neighborhood of x is a member of F, so n belongs to F and m belongs to F, so n intersection m also belongs to F, because we know that any filter is closed under finite intersection. So n intersection m belongs to F. But here n intersection m is equal to phi. So this implies that phi belongs to F, which is a contradiction because we know that no member of a filter is empty. And so we arrive at a contradiction. That means our assumption is wrong. Hence, F must converge to a unique limit point. Conversely, let every convergent filter on X have a unique limit point. Then we have to show that Xt is Hausdorff. If possible, let Xt not be a Hausdorff space. We know that if space is Hausdorff, then for every pair of distinct points X and Y of X, we can find two neighborhoods of X and Y respectively such that those neighborhoods are disjoint. But if space is not Hausdorff, then we can find at least one pair of distinct points X and Y of X such that their neighborhoods are not disjoint. That means an intersection M is non-empty for every neighborhood n of X and for every neighborhood m of Y. As n of X and n of Y are filters on X, because we know that these are neighborhood filters, and we have proved also n of X and n of Y are filters on X, then n of X intersection n of Y is also a filter on X, because we have proved that intersection of any two filters is also a filter on X. And so n of X intersection n of Y is also a filter on X. And we have also proved that any filter is a filter base. So n of X intersection n of Y is a filter based on X. Then the filter F generated by n of X intersection n of Y is a filter finer than both filters n of x and n of y. As n of x converges to x, so filter f converges to x. Why? Because we have proved that if any filter converges to x, then any filter finer than that filter also converges to that point. So f converges to x. And since n of y converges to y, so the filter f, which is finer than n of y, so this also converges to y. That means f converges to both points x and y, which is a contradiction, as we have assumed that every filter converges to a unique limit point. And so our assumption is wrong. Hence, xt must be Hausdorff. Thank you.